Hi, I'm Cassie, and I'm going to walk you through question 40 of the AAMC's official physics question pack. So this is the first question associated with passage 7 of the pack, and this question is all about the Doppler effect. Now, how do I know it's about the Doppler effect? Well, if you go back and review passage 3, that passage was also all about the Doppler effect. And I talk about in those questions how the Doppler effect is all about relative motion. When you have something emitting a sound, so the source of a sound, like let's say an ambulance, and you have something that hears the sound or observes the sound, like a person who's in traffic as the ambulance is going by, when those two objects are getting closer together or when they're getting farther apart, the thing that hears the object is going to hear a different frequency than the actual frequency that the ambulance is emitting. So it's either going to be a higher frequency if the objects are getting closer together, or a lower frequency if the objects are getting farther apart than that actual frequency that the ambulance is emitting. So let's think about why that is. Well, if you have an ambulance and you have ambulances coming towards you, right? So there's relative motion and the ambulance is getting closer to your car. As the ambulance moves towards you, it's actually compressing the sound waves in front of it. It's making those sound waves have a higher frequency in front of the ambulance. Those waves are getting closer together in front of the ambulance. That's their definition of frequency, right? More waves closer together is equal to a higher frequency. And that should be easy to remember because you know that from your personal experience that when that ambulance is getting closer to you, that sound, it comes across as much higher pitched. And what is the difference between frequency and pitch? Well, you can think of them essentially for the purpose of the MCAT as pretty much the same thing. It's just frequency is an objective, measurable quantity. Like let's say the ambulance might be letting off a frequency of 10 hertz. And then pitch is just the human perception of that frequency. So as that ambulance gets closer to you, you hear a higher frequency, which is the same thing as it comes across as being a higher pitched sound. Now, this question is asking about the opposite case, though. It's asking about what happens when the thing that's emitting the sound, like the ambulance, and the thing that's observing the sound are getting farther apart. So then, of course, just the opposite happens. Instead of you perceiving the frequency as being higher than the actual frequency the ambulance is emitting, you're going to perceive that frequency as being lower than the actual frequency that the ambulance is emitting. So if we take a look at our answer choices to see which one matches that case, that for me is answer choice C. The farther our source and our observer get from each other, the lower in frequency the observer is going to perceive that sound. So I hope this helps. If this helps, give this video a like. Make sure to go back and review passage 3, which is also all about the Doppler effect, and subscribe to my channel for more content like this.